Hi guys. So today we'll be covering polynomials in applications to length, perimeter, and area. So look at the image and basically think of a garden, a concrete slab, or even just a house, or just a certain work area that you're trying to make sure that you have the right amount of space for. Now, space implies that you have a sense of length, a sense of perimeter across every side, and then the area, the total amount of space that you can actually store items in or content within that parameter. All right, so basically, we're going to start by finding length. Now, we have all these expressions representing certain side lengths. So, we're going to use these expressions to figure out what our missing sides are. So, I'm going to use this highlighter and basically show you that 7x plus 6 represents this entire side, A to E. Okay, so that's something to kind of notice. Now, what we do notice also is that we are looking for A. All right, we don't know what A is, and A is the bright red, right? Now, one thing's to note is that on the opposite side, A plus G of F. So A is representing DC, right? And if you notice, DC plus GF should equal 7x plus 6, right? Do you guys agree? So if you notice that those guys actually have to be equal to each other, we can go ahead and solve for A with that setup. So here I am using red for the math. So here we go. So we know, okay, that A plus the x plus 1 should equal the 7x plus 6. Now, to find what a is, we really have to isolate the variable. And notice how we're really just working with the expression, okay? We're not actually going to get just a numerical, we're going to get an expression. So let's subtract the x plus 1 real quick from the 7x plus 6. So really what's going to happen here is a is going to equal 7x plus 6 minus the x plus 1. So notice right there, our problem really is just a subtraction problem. We're just trying to find the missing piece, which is a. So we can combine like terms, right? So 7x minus, notice how there's the minus there, minus x, all right, 1x. So 7 minus 1 is 6. Don't forget the last name. So you have a equals 6x for the first term. And then the next term, our constants, 6 minus, again, notice the symbol, minus 1 is 5, positive 5, so plus 5. Oops, my pen did a little thing again. Silly pen. All right, so that would be the expression that best represents A. Okay, so let's move on to B. All right, we're going to go ahead and find B. So let me get my handy dandy highlighter. And we notice that B is really from A to D. Okay, that side. Now, if we look on the other side, the matching side would be EF, right? Plus GC. So that's something to notice right there. So you can go ahead and set it up in that setup. We know that B should equal um, EF, which is 2x, right? Plus uh, GC or CG, which is x plus 1. So we're just going to add them together, right? 2x can be combined with 1x, so that'll give you 3x. And then the 1 is all by itself, so he just moves down. And there you go. B equals 3x plus 1. So that's the expression to represent b. Okay. So again, you're just kind of bouncing back between opposite sides, seeing what pieces match with what. It's like a puzzle. So think of it like a puzzle. All right, so your turn number one. Find the expression that represents the lengths of a and b. So very much the same process as I showed you. Go ahead and see if you can do it on your own. You might be using addition. You might be using subtraction. That's really for you to figure out. So test yourself, see how much you know. And just a little side note: 6x plus 3 does represent a e, that whole side. So just be aware of that. Okay. All right. So moving on to the concept of perimeter. Now, with perimeter, again, some of you have already learned it in middle school, but perimeter is really AKA the fence. Okay. So AKA the fence. All right, the outer fence. All right. So basically, what we're really focused here is on. Let me use the highlighter here. All the way around to here would be a fence. To here, to here. So notice how I'm just focused on just the outer part, the outer fence. Maybe this is the backyard or something. I don't know. Okay, but this would be the fence for that backyard. All right. So basically, we're just worried about that. Now, the thing that best represent it is, well, all the sides, all the outer sides, and they're all represented by this expression. So we really have um, this guy, right? 7x plus 6. So again, here's our setup for our perimeter, p, all right, for perimeter. 7x plus 6 plus the 2x, right? Plus the x plus 1 plus, looks like we have another x plus 1 representing CG, right? So covering that part of the fence. And 6x plus 5 here. So notice how I'm just combining all these sides of the fence or slab. Really depends on application. And 3x plus 1, which represents side AD. All right, so let's go ahead and combine like terms. We have the 7x plus the 2x plus the 1x plus another 1x plus 6x plus a 3x. So let's go ahead and combine those first. So 7 plus 2 is 9, right? And then 9 plus 1 is 10, plus another 1, 11, and 11 plus 6 is 17, and then 17 plus the 3 is 20. And don't forget, we're combining the x terms. So our last name is 20x. Now, let's deal with our constant terms. So 6 plus 1 plus another 1. So we're at 8 so far. Plus 5 should give us 13. And then plus this last one right here. So that's 14. So our perimeter is best represented by this expression right here. Okay, so again, perimeter just means count the outer fence. Notice how I'm not really focused on BG because that's not the outer fence. I'm just worried about the outer edge. So you just combine them, add all those expressions up. Okay, and then like terms, and there you go. All right, your turn number two, same concept. You are working with the perimeter. So again, just like my previous example, try it out and show me what you got. All right, so the last concept is area. All right, how much can we really fit inside? Okay, so first things first is we need to notice that we have two different rectangles ultimately, right? We have rectangle one, and then we have this bigger rectangle, rectangle two. Now, if we were to find the area of this entire object, both rectangles, okay, rectangle 1 and 2, we have to find their individual areas first. So how do we do that? So there's several ways, and I'm going to show you the most straightforward one. we're going to find the area of both these rectangles and then combine them, which means add. So remember, area is really length times width. So we're going to find the larger rectangle first for their area. And remember, length times width. So width could be represented. So again, we have, let me use a highlighter here to make sure we understand why we're using these expressions. 6x plus 5 really does represent the width of the larger rectangle. Okay, the length can be represented by AD, which is 3x plus 1. All right, so that will be our length and width that I'm going to use to find our area. So again, here is our width, here is our length, and we're going to go ahead and apply the area formula. So area equals length times width, which is 3x plus 1, times our width, which is 6x plus 5. So now we can go ahead and distribute. So again, the 3x will multiply to both terms, all right, in the other cell. So 3x times 6x, and the 3x, thank you, pen. That pen makes my year so enjoyable. 3x times that 5. All right, but don't forget, this 1 is also going to distribute to both terms in that cell. So we're also going to have and 1 times the 6x. Thank you, pen, for, again, I think it heard me, and it's just like, I'm going to mess with you now. There we go. So 1 times 6x, and the 1 times the 5. All right. Now I know you're like, Mr. Webb, can I just do it in my head? If you can, but I just want you to play it safe. Use the distributive property. It'll help you later to catch any mistakes. All right, so now we have 3x times 6x, which is 18x squared. Okay, don't forget when you're multiplying the x's, x squared, because the exponents of 1, right? 1 plus 1 is 2. All right, and keep the base stays the same except for the 3 times the 6. That's why it's 18x. All right, so 3x times 5, that'll get you 15x. Very nice. 1 times 6x will give you 6x, and 1 times 5 will get you 5, and you're almost there. Can we combine like terms? Yeah, we can combine those two guys. So we have 18x squared plus 15x plus 6x, which is 21x, and plus that 5 constant term. So the area for triangle 2, okay, for the larger triangle is this guy. Now, is that our complete answer? No, that's not our complete answer. It's a part of it. It's a part of it. So I'm going to put a star next to it because that's pretty important for the last part that we have to do. Okay, so that's one part. Now we have to find the area for the smaller rectangle. Again, area formula is still the same, length times width. And I'll go ahead and use a different color code for the highlighter here so you can understand where I'm getting my numbers from. I'll use x plus 1 as my width and 2x as my length. All right, that's a pretty ugly orange there. All right, so I'm going to go ahead and use an entirely different color, I think, for this, just so we can make sure we differentiate what I'm doing here. There we go. So again, smaller triangle will be area, length times width. My width, I'll let that be x plus 1, and my length, 2x. So our length was 2x times our width, which was x plus 1. And we're going to go ahead and distribute, and we'll multiply. So we have 2x times x, which 2x times x and, or plus, 2x times, whoa, thank you, Pin, 2x times that 1. So you should get the area equals 2x squared plus 2x. And that will be the second component we need to find our actual answer. So this is the final setup. The final countdown. All right, I'm gonna use purple. So the total area, all right? The total area for this I don't know, this backyard, this house, this concrete slab, um, a pool, who knows, all right? It's just one of those things where now we have the area expressions for both small rectangle and the large angle. So we have or triangle. So now we have to combine them, all right? So we're going to take this area here and this area here, and then we're going to combine them. That means we're going to add them. So total area, let me go ahead and use the color coding here. We have the large area, right? 18x squared plus 21x plus the 5. And again, that was the from right rectangle 1 and triangle or not triangle 1, rectangle 1. Sorry, getting my objects mixed up in my head here. There we go. Erase. So again, that was rectangle 2. Keep wanting to say triangle because my geometry classes. Ugh, and then I have to change the color at the same time. Men can't multitask. There we go. So again, rectangle 2 plus. So again, we're adding this guy to the other triangle, his area, triangle, or not triangle, rectangle 1, 2x squared plus 2x. All right. So basically, that's how we're going to find the total area. Now, combine like terms, we can combine those two, right? And we'll get 8, no, not 18, sorry, 20x squared. Okay, because again, we're adding, so be aware of what we're doing there. And if you're already ahead of where I'm at, that's just because technology is kind of slowing me down right now. 2x or 21x can be combined with 2x. That'll give us 23x. And it looks like the constant 5 here can't be combined with anyone, so he's just on for the ride. Okay, so it looks like our total area, or our expression to represent our total area, is this. Okay, and that would be the final answer. Okay, so this is actually a multi-step type of problem. Notice how you have to multiply and get here, and then multiply again to get here, and then combine them later on to get your actual final answer, because it's not just the area of rectangle 2, it's 2 and 1. So you have to combine both the areas together, okay? All right, so there's your turn number 3. Find the expression that represents the area. Go ahead. This will be probably the harder of the 3 your turns. And again, try it on your own. See how far you can get. And yeah, see what you get. And if you're stuck, let me know. All right, guys, have a great day. And again, ask me questions.